This is AP Precalculus, notes topic 3.8, the tangent function. So we're finally adding tangent because those are the three basic trig functions that we're supposed to be talking about, right? We have sine, we have cosine, and then we have tangent. Tangent is our investigation today. So there are three different ways that you can memorize tangent. The most fundamental way is knowing that it is the sine of theta divided by the cosine of theta, which makes a lot of sense because sine gives us the y coordinate, cosine gives us the x coordinate, so it's kind of like y over x. And whenever I have the change of y divided by the change of x, that's also known as slope, which is why we have m written here, which is slope. So there's three unique ways that you can memorize tangent, and all of them are equally valuable depending on the context. So when we are in the top right quadrant, notice what happens when we go between 0 to pi over 2. Again, pi over 2 is this angle at the very top where 0 is over here. Every single time that we have 0 for tangent, we have a slope of 0. Really what I'm going to be doing for most of these, and I'm using this definition that tangent is really equal to the slope. And I really care if I'm 0, a horizontal slope, if I'm a positive slope, if I'm a negative slope, or if my slope is infinity or undefined, depending on your context, right? So in the top right quadrant, when I'm between 0 and pi over 2, in this top right quadrant right here, that's quadrant 1, notice that all of these slopes are positive. So that's kind of good to know. They are positive. And it just gets steeper and steeper and steeper, more and more positive. But once it gets all the way up here, we have a slope that is so steep that it's infinity. So some people can say that the slope is infinity. That's what we can say down here. But usually what we say here is that the slope of the vertical line is undefined. Undefined instead of infinity. But you can say, hey, if we take the limit as we go close to pi over 2, again, pi over 2 is this angle that is pointing straight up, so we have like a 90-degree angle. As I get closer and closer to this angle from the left, that means I'm going from this direction as opposed to from this direction. If I had a plus sign right here, I'd be going from the left sign, which would still have the same answer. If I go into tangent, this goes to infinity, and it does. So that's the only way that you're allowed to actually use infinity, technically, by using limit notation. Okay, what about in quadrant 2? So in quadrant 2, that's in between this pi over 2 angle and this pi angle. So we're in between these two values. In this second quadrant, this is quadrant number 2 now, and this was quadrant number, did I write down quadrant number 1 up here? In quadrant number 2 now, we are going and having a negative slope, a negative slope, a negative slope, a negative slope, and a 0 slope. So all of these slopes were negative. And I should probably circle the positive up here. So I went positive to negative. Interesting. What happens when we go, we go from negative infinity all the way to 0. Again, when we have no slope or this horizontal slope, that's 0 slope. What about if we go even further? If we go into quadrant 3 down here, ooh, I forgot my 3. If we go into quadrant 3, I have a negative slope, a negative slope, a negative slope, and a negative slope, and eventually undefined. So again, you have a 0 slope all the way to an undefined slope. But again, most of the time, we have a negative slope down here. Whenever we have an infinity, you're not allowed to do that. That's undefined. So every time that you do that, you're going to see a vertical asymptote. Vertical asymptote. And here's what it looks like on a graph, right? So on a graph, you have these dashed lines right here, Notice where they happen. Pi over 2. Well, on the unit circle, pi over 2 is pointing straight up when the slope is undefined. That's why we have this asymptote right here. What about this 3 pi over 2? Well, 3 pi over 2 corresponds to this angle pointing straight down. Again, the slope is undefined, and we have a horizontal a vertical asymptote. Horizontal would have been that one, right? So vertical asymptote. And the equation of a vertical asymptote is x equal to that number. So in this case, it's x equal to pi over 2, or you can say x is equal to 3 pi over 2. And it's interesting to note how much distance has happened between these two spots, because that's where it really repeats, right? This repeats over and over, and the distance between, well, I guess it's easier to do pi over 2 minus a negative pi over 2. This entire period here, do I have enough room to write it? The period, unlike cosine and sine, which have a period of 2 pi, the period is pi. Interesting, right? And then if we went even further and we went down in here to quadrant 4, you'd see that all of these slopes are negative again. And the pattern here goes like this. It goes positive, negative, positive, negative. It alternates every other one. This makes a lot of sense if you know the acronym All Students Take Calculus, because all cosine, sine, and tangent functions are positive in the top right. In the top left quadrant, in quadrant 2, only the sine is positive, and therefore tangent is negative, and cosine is also negative. In the bottom left, we have a t, meaning tangent is positive, and indeed it is, where cosine and sine are negative. And in the bottom right quadrant, in quadrant 4, only cosine is positive, meaning tangent is negative, and also sine is negative. So cool little acronym that'll help you out. Let's try and do the analysis down here. So it says that, yep, A is the vertical dilation, although I'll give you a hint for tangent functions. It's really, really hard to figure out what the value of A is because there's no really defined values other than pi over 4, 1 on this graph. If you go to pi over 4 and it goes up to 2, then you can say, okay, well, the value of A is 2 because we multiplied by 2. But most of the time, you're going to have a hard time figuring this out. But if I have to pick 2 points that are really important, star them. Those are the 2 points that are really important. At pi over 4, I should come to a height of 1. At negative pi over 4, I should go to a height of -1. Other than that, you don't really have anything to rely on. The period now is interesting. Remember that when we had cosine and sine, our period used to be 2 pi over b because the period of sine and cosine was 2 pi. Now that the period is pi for tangent, our period is pi over b. And again, the period is always going to be the absolute value. It's always going to be a positive number on the inside here. Phase shift is always the opposite. It's a plus c, but now it's a negative c units. And vertical translation, again, by d, there's no opposites there. So all of this stuff is kind of review. I would say if I had to star anything, this is the most important thing because period has changed. Additionally, it's kind of interesting to talk about those vertical asymptotes, which is for some reason not added to this table, and I feel it's very important to know. So let's talk about the vertical asymptotes. I usually just say VA because I'm lazy, but if you want to spell out vertical asymptotes, again, you don't pronounce the P. This is how you pronounce it, asymptote. If you pronounce the P, you also pronounce pterodactyl as pterodactyl, which is weird, but whatever. So vertical asymptotes happen at whenever the inside, I'll say when the inside, and I'll put quotes around that and explain what I mean by that in a sec. When the inside is set equal to a bad value, either pi over 2, or you do negative pi over 2, or you could do, what's another one? Or 3 pi over 2. All of these are bad values. Usually I just choose the first one, pi over 2. This is a bad value. Why? Why is this bad? It's bad because if you look at tangent again, at pi over 2, when I point straight up, that means I have a slope that is undefined. That is the first bad value. And then I have a bad value down there. Then I keep rotating until I get another bad value right there. Then I keep rotating until I get another bad value down there. There's an infinite number of bad values, but the easiest and simplest one is pi over 2. So what do I mean by inside? Inside means everything inside the parentheses right here of the tangent. If you set whatever's inside 2 pi over 2, you will find those bad values, and those bad values generate vertical asymptotes. And they will always be of the form x is equal to a number, because vertical asymptotes mean you have x equal to a number. Horizontal asymptotes means y is equal to a number. All right, let's continue on with this lesson. So in example 1, we have a graph, and I want to find the constants of a, b, and d. So the first thing that I'm noticing is a, I can't really tell what's going on. I noticed that about halfway between here and our asymptote, which is what we did back over here, right? Halfway between here and the asymptote, I have a height of about 1. So halfway between here and the asymptote is right about here, which is about the height of 1, which means a probably hasn't been changed. But again, the strongest I can say that statement is it's probably 1. So here's how I'll say that. I'll say a is around 1, I would guess. What about B? B is something that's a little bit more exact because B affects the period. So notice that back over here, there's another way to think about this. The period is, it's pi, of course, but the way that you can figure that out is the vertical asymptotes are splitting this period in half, 1/2 on this side, 1/2 on this side. So take your period, divide it in half. 1 is ahead and 1 is behind. So back over here, we split up our period and then divided it by 2. What did we divide by 2 in order to get pi over 4? You're right, it was pi over 2. Another way of doing the period, so the value of b here, I'll say the period is equal to pi over 2. There's another way to get that just other than a graphical interpretation of saying, hey, if I have to go forward pi over 4 and that's half of a period, then I have to double pi over 4 to get to the full period. Another way of saying that is just do this bound minus that bound. Watch me go. So if I say pi over 4 minus, okay, what's the other one? This one is a negative pi over 4. I'm just subtracting them. Minus a pi over 4. I have a double negative. They kiss and become positive. So this is going to turn into a pi over 4 plus a pi over 4. And that's the same thing as 2 pi over 4, which is just pi over 2. And look at that. I already knew the period was pi over 2 using a different analysis. subtracting the bounds also gives you the same period. So how does a period help us? Because we have a formula, right? So the formula for finding the b is period is equal to pi over b. And we happen to know the period is pi over 2. I can substitute it in here and get a new equation that says pi over 2 is equal to pi over b. And at this point, a lot of students can just use logic. If this side and this side have to be the exact same value and the tops are equal, then the bottoms also have to be equal, and therefore b has to be 2. But let's say you didn't know how to do that. Maybe it was something really hard and something even more hard on the right-hand side. You would cross multiply and say pi times b, and then you'd cross multiply the other direction and get 2 times pi, and then you divide both sides by whatever number is out front of b. In this case, it's pi. You'd say divide by pi, and you'd say, okay, those cross off, those, oh, not that one. This one crosses off, and you can say, ah, yes, I found that b is equal to 2 that way by cross multiplying and solving. Either way, whatever floats your boat or sinks your sub, right? So, if I come back here to b, I can say that the value of b is 2. And then finally, I need to find the value of d, right? So d is the midline. The midline, did we shift up and down? No, it's going right through the x-axis at 0, through the x-axis, right? It's going through that middle part at 0, so I'm going to say d is equal to 0 here. All right, what about example 2? So now it's giving us a function, and we need to figure out its period. Whoa, it's period. So again, we're using that fancy formula that says period is equal to pi divided by b, not 2 pi. Remember, 2 pi is for sine and cosine. Pi is for tangent. So I'm going to say, hey, I happen to know the value of b. B is right there. It's a number in front of x. If x is being divided over here, you have to remember that this fraction is really 1/3. But right here, value is just 2. I know that this says b is equal to 2. So I can come back in this form and say, hey, you are a 2. And I can say the period is equal to pi over 2. And there's my final answer. What about in example 3? So we have this function, and we're looking for the vertical asymptotes. So the way that you do vertical asymptotes is you set the inside equal to a bad value. So I'm going to set the inside. I'll say inside is equal to bad. That's how I'm remembering it. So my inside is x over 3. My bad value that I've chosen is pi over 2. It's the first and easiest of the bad values. So how do I solve this? You cross multiply and solve. 3 times pi is 3 pi. Cross multiplying the other direction, 2 times x is 2x. How do I solve for x? Well, I divide both sides by 2. Divide by 2, and x is equal to 3 pi over 2. And then it keeps repeating by whatever the period is. I don't really care what the period is because I notice that all of these first values are all weird. They're all different, not weird. And 3 pi over 2, oh, look at that, 3 pi over 2. That is indeed the correct answer. There's another way to do this question, which is to kind of do the period here, and then you go forward half a period and backwards half a period, but that does mean more calculations. I'll show you the second way, but it's not my preferred way of doing this. So I can come back over here and say, okay, I know that this value right here of b is equal to 1/3, aka the number that's in front of the x. There is no 1/3, but you can see 1/3 right there, times x is the same thing as x over 3. So the value of b is 1/3. So if I come back over here to my formula, I can say that period, I can spell period, is equal to pi over b, and I know that b is 1/3. So I can say that period is equal to pi over 1/3. So I have an embedded fraction, or a fraction within a fraction. Some people call those nested fractions. This means I have pi divided by 1/3. And that's the same thing as saying, okay, I'm going to do a keep, change, flip. Whenever I have fractions and division, it's a keep, change, flip. So keep it, change it, flip it, and now I have 3 pi. So I know that the period is 3 pi. A lot of work just to figure that out. But now I can use that old trick. Remember that old trick that said, hey, you're going to go forward half a period and backwards half a period in order to find where those vertical asymptotes happen. So I'm going to take my period, which is now 3 pi. If I go half of that forward, that will be one of my vertical asymptotes. And if I go backwards half of that, that will be another asymptote. Look at this. Half of 3 pi is 3 pi over 2. So you can do it that way as well. I don't know which way you prefer, but I would assume it's the way I did it the first way. All right, let's try example number 4, and then we have a bunch of tiny problems, and then we're out of here. Okay, example 4. Which of the following could be an expression for k? All right, so I'm noticing that the difference between all of these, they're all tangents, okay, the periods are different. Some of them are 2 and some of them are x over 2. So let's go ahead and do the analysis of what is period. Period, in this graph, is the distance between my vertical asymptotes. So I can just do pi minus a negative pi. So the period here is going to be pi minus the other asymptote, which is negative pi, and therefore it's going to be pi plus pi, which is just going to be 2 pi. which is not normal. Normally a tangent function has a period of just pi. All right, so if I know that my period is 2 pi, I can also use the formula that says that, in pen though, that period is equal to pi divided by b. I happen to know my period, which is 2 pi. I can plug that into this period and say that 2 pi is equal to pi over b. And then I can solve for b by cross multiplication. This is technically divided by 1, right? So I can cross multiply. 1 times pi is pi. Cross multiply the other direction. 2 pi times b is 2 pi b. And then I can divide both of them by pi first. So that's kind of easy. Divide by pi, divide by pi. Those pi's are gone. If something is gone after division. Here, let me go a little bit slower. If I divide both sides in pen by pi, divide by pi, divide by pi, while those pi's cancel out, pi divided by pi is just 1. So it leaves a 1, and I have 2b over here. Or not 2b, haha. Okay, and then divide both sides by 2, divide both sides by 2, and b is equal to 1/2. So that's kind of a key clue. I have to have a 1/2. Therefore, you're wrong. Let's cross off C and D, and I have to choose between A and B. So what's the difference between A and B? They both have a tangent. They both have an x over 2. The only difference is, what is the midline? Well, the midline down here, where does it kind of cross the halfway point? Right about here, which is a -2. Therefore, I want a -2. You don't have to do opposites when you're on the outside. You do opposites when you're on the inside. So correct answer here is just A. All right, and then we have a bunch of these values. So let me show you the quickest way to remember how to do tangent values, which are now going to be started to add to our blue kits and all of our speed sheets and such. So if I have a unit circle, this is something that I probably wish I had a little bit more room for to do. If I have a unit circle, there are, again, really 3 different points that you need to look for. And again, you're thinking of slopes, because tangent is the same thing as slopes. So you either have a slope of the nice easy one of 1, or you have a slope of 1 divided by the square root of 3, or 1 times the square root of 3, which is just the square root of 3. Those are the only 3 values that you can have. But remember, if you're in this top right quadrant, it's positive, and then positive down here, negative, and negative, and then you have to have either positive or negative versions of these. I will note that on the answer keys that Ted Gott makes, he usually puts 1 over the square root of 3, which is totally mathematically acceptable. However, this denominator is a radical, and typically speaking in math, you don't want to do that. So let me show you really quickly. If you have 1 over the square root of 3, in my class, I would prefer you to go a step further and memorize this as a slightly different number. I'm going to multiply in bottom and top here by root 3 and root 3. The top is now root 3. The bottom is now root 9. And the square root of 9 is 3. So the square root of 3 over 3 is how I like my class to memorize it. I'm going to go ahead and box that, put a star by it. Remember this, that this one is not 1 over square root of 3. I mean, it is. But in my classroom, I want you to write this one as the square root of 3 over 3. So there are really, I guess, 5 different possibilities. Either you have a slope of 0, you have a slope that's undefined, you have a slope of 3 or root 3, a slope of 1, or a slope of square root of 3 over 3. Then you have to make sure if it's positive or negative. So start memorizing those. Here we go. Pi over 6. Let's go ahead and graph that one. Pi over 6 lives right there. This slope is very small, so I'm going to say that that one is 1 divided by the square root of 3, but I don't say that. It's actually root 3 over 3. And I always double check at the very end. Am I in the top right quadrant? I am. It's positive. Okay, moving on to B. Pi over 4. So pi over 4 lives right here. That's a slope of 1. Done and done. What about tangent of pi over 3? Pi over 3 lives right up here. Pi over 3 is a bigger value, therefore the answer is going to be square root of 3. Again, making sure I'm positive, I'm good. Making our way to D, 5 pi over 6. 5 pi over 6 lives right here. Notice that I am going to have a negative value because I'm in quadrant number 2. It goes positive, negative, positive, negative. So I have a negative value, and this is a very slightly, not very steep slope, so it would be like divided by square root of 3, therefore it's root 3 over 3. What about E? 4 pi over 3. 4 pi over 3 lives right here. Notice that this slope is very steep, therefore it's going to be a square root of 3. And be careful, it goes positive, negative, positive, so I got it right. It is indeed a positive. And then I move to 7 pi over 4. 7 pi over 4 lives right here, and that is a slope of 1, but notice that it's a negative slope, so the answer is going to be a negative 1. And then I go to G. 3 pi over 2. 3 pi over 2 lives straight down. This is an undefined slope. You can't say infinity. You can't say negative infinity. You need to say undefined. And then I move on to tangent of pi. Well, pi lives straight out to the left. What is the slope of the line that does this? That's a slope of 0. And then finally, tangent of pi over 2. Pi over 2 lives straight up. Again, when I have a slope that goes straight up, it's a slope of infinity, but I can't say that, so I say undefined. Whew, that was fun. All right, that concludes our notes for topic 3.8, the tangent function. Thanks for watching, guys. There's all of the pages, back, middle, other middle, and front. I'll see you guys later.